Welcome everyone to today's presentation. Again, my name is Kindred Cooper, and in the background we have Clayton Petmiller running the Q&A. Let's go ahead and get into this. We got a lot of material to cover. I've tried to take these categories or tried to take these tips and categorize them, and that's difficult with some of them because there's some crossover. But the main categories we're going to look at is the application, the interface. We're going to talk about some tips in the sketch environment, tips in parts and assemblies, presentations as well, and the drawing environment. Granted, Clayton and I could probably talk for 3 days straight of all the tips and tricks we know inside of Inventor. We just don't have that kind of time, and we can't cover everything. So there's a lot of other sub-environments and areas in Inventor where there are definitely some workflow tips and tricks you can utilize. But for this one, we're going to try to keep it as simple and streamlined as possible. Plus, I took all these tips and went to our customer feedback. What are customers asking about? This is new users, semi-seasoned users, if you will, and some of the experienced users. What are a lot of the things they're calling us and asking us, how do I do this? Or how can I get this to work a different way? And that's where the bulk of these tips come from. So there are a few in here that are going to be geared around the new users especially, but there's also some for some experienced users and a few for some of the advanced users. So hopefully everybody finds something that they can use on their daily workflow. So the very first tip I have, this is a personal tip of mine. For your graphics hardware, what card do you use? This more or less comes into play with the later editions of laptops that we've been seeing. A lot of the laptops are being built with dual graphics cards. They're coming with the Intel integrated graphics, as well as some other card. Could be an AMD card, could be an NVIDIA card. So they're coming with two video cards. And the way it's designed to work is Windows is supposed to use the Intel card for your low-level, low-intensity graphics needs. That's things like loading the operating system, Word, email, internet, things like that, solitaire. And it's supposed to switch over to the other card when the graphics become too much for the Intel card. It needs more horsepower. The problem is Windows does not do a good job of doing this switchover. So when you go into a video game, a high intensity video game, or a CAD product, many times Windows is not making that switch. It's still relying on the Intel card, and you have program or software performance issues with that. So then you introduce, are we talking about a gaming card like the AMD Radeon, or are we talking about the GeForce from NVIDIA? Assuming it's one of those cards that comes with it, my personal advice in this is to go into the BIOS and disable the Intel card and solely rely on the secondary card. Rely on the main horsepower card. Simply because you can't rely on Windows to make that switch over for you. So I actually had to do this on my own Dell laptop. I had to go in and disable the Intel card in the BIOS. And once I did that, all of my graphics problems disappeared immediately. Now, are you running a gaming relative card, or are you running a CAD and simulation geared card like the Radeon Pros or the NVIDIA Quadros? These two different avenues have different performance capabilities based on what you're using. A Radeon and a GeForce card will run CAD. Yes, for the most part, they will work. But you can suffer some performance issues running those. You might not get the best response times, the best movement of your model, especially on a very large model. Whereas the Radeon Pro and the Quadro cards, they are geared exactly for that. Working with those larger model files, getting better color fidelities when you're running simulations and working with physics and things like that. So my recommendation, if you can choose and have that ability to say, give me a Radeon Pro or an NVIDIA Quadro, definitely go down that road. They are more expensive, but they are worth the money. All right, so let's get straight to the demo. Starting out, we've already covered the certified graphics, or sorry, the graphics. There is a certified list from Autodesk. If you type in Inventor certified graphics list into any search engine, it'll take you right to it, and that gives you a list of every card, both AMD and NVIDIA, what the card version is, what the name of the card is, and the driver that has been certified by Autodesk. My recommendation is, of course, always run the latest driver if possible. Now, for the interface of Inventor, let's talk about Annotation Scale. So here's one that has come up quite a bit. If I look at, say, I'll just, let's go with that one. So starting out, Inventor out of the box runs an annotation scale of 1. And if you have good eyes, that works. You're comfortable with that. As you age, that's not always the case. So I've actually had to bump this up over the years as I've gotten older. Under the Tools ribbon and Application Options, slide this over a little bit, on the General tab, about halfway down, there's a dial button or an up-down selector button for Annotation Scale. And this allows you to tweak that graphical annotation from sketches. So if I set it to, say, 1.5 and I hit apply, you'll notice all of the dimensions resize, become a little bit more legible. But it's not just the dimensions. Things like the UCS icon or the origin icon, any of the sketch points that show up that you placed in a sketch, or even projected geometry, the dot from a projected piece of geometry, all of that resizes and makes it a lot easier to see on the screen. So as you see, the origin indicator resized as well. So it's not just isolated to dimensions, but it does make things a lot easier to tweak that. So if you're struggling with that, definitely give that a try. You can set this all the way up to 5, and that's the maxed setting for it. All right, let's talk about multiple views of the same file. So take, for example, let's go with something like, let's try this guy right here. So we've got a joystick controller, we've got half of a joystick controller for a gaming system. And if I want to see multiple views of this model at the same time, if you go to the View ribbon tab on the Windows panel, there's a New command. What this does is it opens up a new view of that same file. So if you look across the bottom, I've got the exact same file open with 2 different views. So maybe I'll set this one to that view orientation. And I can use the view cube as well if I want perfect alignment. Create another new view, and I'll go with the side. Actually, I'll go with that one. And one final one. And for this one, I'll do, let's do this end, like that. So if I want to see all of them at the same time, I can use the arrange icon, and I can see all 4 of the same file. So this allows you to get that different view angle of each one, and you can see those model changes. Anything you make, you can see it from different angles all simultaneously. And then you can close out each one of them that you don't want to utilize anymore. And again, it's all the same file. Next, we're going to look at post-its. So in the interface, this happens in a part file or an assembly file. There's the option to incorporate post-its or notes. I've actually seen them called both. The notes option, when you open up a file that contains notes, over in the browser tree, there is a call out for notes, and you can expand that and to see all the different notes that you have. So I can double click on note 1, Takes me in here and allows me to see that note, see what that note is, when was it made, and there could be a screenshot associated with that note. If I look at the other one, you'll notice it's a different note entirely and a different screenshot. So how do we incorporate these? How do we use them? Well, if I zoom in right here and I simply right click, I can create a note. And what you're actually doing when you zoom in, you're capturing this area. So you're setting the focal area for the note. And when I create the note, it takes me into the note editor and I can type in whatever note it is. Try that again. Why it's not giving me the ability to type that in, I don't know. Weird. My keyboard's not giving any feedback. Okay, apologize about that. But nonetheless, it still created the note at least. So then now I have a note 1, note 2, and note 3. When I edit note 3, I can see what that note is and see that focal area. And again, you can incorporate these into parts or assemblies. Moving on down the line, let's talk about some of your custom profiles that come up. So you have the ability to take a custom profile and publish it to the Content Center to use for tubing and pipe. That is inherently in the software already. But there's also situations where maybe you're not using the routed systems, you're not incorporating those into tube and pipe or into that workflow. You just need a custom profile for a very short piece of tubing or extrusion or whatever it is. You can actually incorporate those into your template. So in my standard template, if I launch a standard template, you'll notice over in the browser tree, I just have model states, view reps, and origin. That's all that's there. Whereas if I launch my custom sketch profile template, looking over in the folder tree now or in the browser tree now, I have model states and I have a blocks folder. Now we're going to cover blocks a little bit more in depth in just a minute. But if I expand the blocks folder, I have different block shapes already built into this template. So very quickly, I can start a sketch, locate a block I want to use, right click on it, place that block. There's all of my sketch geometry already there. Constrain it, finish my sketch, and immediately extrude it to whatever length I need. You build these into the template by opening the template itself and defining the geometry from there. So you would not click on new for this operation. In order to make this edit into the template, you're actually going to go to the open command. You're going to browse to your templates folder and open up your source template, be it IPT or the IAM, which we'll see in a few minutes for another workflow. So the IAM that I just mentioned, there's the option for virtual components. And you might think, okay, well, wait a minute, what are virtual components? Virtual components are components that you either cannot create a model of or you don't need to create a model of. So what are some examples of that? It's components you want to have call out on a bill of material, but there's no model of it. There's no geometry. How do you get it to show up here? And one of the easiest ways to do that is to create a virtual component. That is what this option here does. Using the create command, when you check virtual component, you'll notice that the template selection is grayed out. Also, the file path gets grayed out. So you're not creating an actual file. You're creating more or less a call out in the bill of material. You're creating metadata that's associated with this particular assembly or with this assembly template. You do have a bill of material structure, so you can identify, is it a normal BOM structure? Is it a purchased item? Is it a phantom or a reference or something like that? So what are some examples of this? Some good examples of this are any kind of lubricants or grease that you might need to have called out in your assembly. But again, you can't really create a feasible model of grease. Another good example is any kind of maintenance manual or assembly manual. An extra parts bag or packet or something like that is another item. So if you want to incorporate these into your template, again, you're going to open your source template and make those changes there. Once you have those changes incorporated, they become part of your template. So now when I launch a brand new assembly, looking over in my browser tree, I have a folder for virtual components. Now, this folder, I'm going to show you how to create that a little later as well. But you'll see I've got grease, I've got a maintenance manual, stretch wrap, product labels, palletization, packaging, extra parts bags, anything like that. And if you go to your bill of material, there's each one of those items called out. You also have that bill of material structure associated with them. Now, if there's some of these that you don't need for this particular assembly, okay, you don't have an extra parts packet for this particular design, that's fine. Just come in here and delete it. It's gone, no harm, no foul. And it's also out of your bill of material. So you could build your assembly template with all of these virtual components. And we do have some customers that have 40 and 50 different virtual components to cover all of their designs. And when they start a new assembly, they simply come in here and delete what they don't need for that design. Now, they might do that in the beginning or they might do that in the end of the design process. But bottom line, they have that capability to come in here and tweak what they need and don't need. On the workflow of templates, one more item to look at is sheet metal. So when you launch a brand new sheet metal template out of the box, you have two different sheet metal styles. You have a default and a default millimeter. And what the sheet metal style does is it controls everything from the material you're working with to the thickness you're working with to the reported bend angle, your flat pattern punch rep, and all of your different features of your sheet metal, from your bend reliefs to your relief depth to your corner options, all of that. The nice thing about sheet metal styles is you can configure it for a particular material and a particular gauge of that material, and each one will show up as a separate line item over here that you can switch to. So again, you would configure this in your template. Here's what it looks like in the daily production. If I needed to start a new sheet metal part with my sheet metal styles pre-built, I simply launch that part, come to my defaults, pull that down, and I've got a cold rolled steel 16 gauge. I've got a mild steel 11 gauge, 12 gauge, got some stainless steel in here. And as I change, all of those settings change based on what the material is and what the gauge is. So you see, as I step through some of these, you're seeing some of these options over here change for you. Building these for the part, the assembly, and the sheet metal, building these capabilities in your template is a huge time saver, instead of doing it every single time you have to come in here and start a new model. Now we're going to move into the sketch mode. So working with sketches, one of the most common things I get is, well, we've got all of these AutoCAD files. Can we use them? So right here, we've got an AutoCAD file generated from scratch in AutoCAD with all the AutoCAD dimensions. Can I use that in Inventor? Yes, you can. The short answer is you may not want to, and I'll cover that in a second. What I'm going to do is I'm going to go into a standard piece part. I'm going to start a new sketch. And in that sketch mode, I have the ability to insert an AutoCAD file. What this actually does is it launches a little translator utility. Now, I don't normally use this workflow. The reason I don't use this workflow is I don't like waiting on the utility. As you see, I'm still waiting on it. The translator utility is a good little utility. There's a lot of things you can do in here. You can turn off what layers you don't need, any objects you don't need, hidden lines, center lines, phantom lines, things like that. And you can also choose to bring in all of the AutoCAD geometry, or you can turn that off and say, well, I only want to bring in, well, mess up my selection here, only want to bring in that geometry. So you can actually window around what you want. Stepping to the next screen, it will automatically detect the units. You can change that. You can choose to constrain the endpoints because this is AutoCAD geometry, and for the most part, AutoCAD geometry does not have constraints. You can also choose to apply geometric constraints. So when it sees a horizontal line, it will apply a horizontal constraint. Tangent, line, and circle, it will apply a tangent constraint. And it does a pretty decent job at doing that. You can also convert AutoCAD blocks into Inventor blocks. When I click Finish, it drops it on the screen, and you notice I don't get a choice of where it goes. I have to move it after the fact. Also, if the AutoCAD dimensions have not been exploded, then it converts the standard AutoCAD dimension into an Inventor dimension that is associated with the geometry. So that means you can change that dimension and it drives the geometry. And that's why I said you can sort of use the AutoCAD drawings. If your AutoCAD drawing has multiple or all of the dimensions exploded, then you're probably going to be better off time-wise recreating it from scratch in Inventor, because this is going to be a lot of cleanup that you're going to have to do to come through here and get rid of those exploded dimensions. So you can use that utility to bring in your AutoCAD stuff. But again, I don't use that utility simply because I don't like waiting on it to fire up. Now, the first time it fires up, it's slow, but gets faster every time after until you shut down Inventor. The workflow that I use instead is I will simply take the AutoCAD file and I'll open it directly in Inventor. This is what it looks like when you open that in Inventor. Then I'm going to take and just window around what I want, right click, copy, come back over to my part and my sketch, right click and paste. And you'll notice almost instantly I have the ability to place it somewhere in my sketch area. Now, before I actually pick that placement location, I'll right click again and I'll go into paste options. In paste options, you have the ability to change the units, constrain endpoints, geometric constraints, AutoCAD blocks to Inventor blocks. Then I can actually drop it somewhere I want it to go. And at which point I could move it, constrain it, whatever I need to do. The copy paste workflow by far is so much faster and more efficient. All right, moving on to another item for sketches. Let's talk about line formats. This is another one that comes up quite a bit where users are not fully comprehending the different benefits of using line formats and some of the takeaways from them, what they can be used for and what they can't be used for. So you'll notice right here in this particular sketch, I've got a solid cube or solid rectangle, square. I've got a solid circle. Then I've got a dashed or dotted circle. I've also got a center line square. And I've got another center line square that is not quite as thick. So here's the difference between these. If I finish that sketch and I click on extrude, notice very carefully, well, I didn't mean to dock it. Notice very carefully, what does the extrude command pick up? If I hover over here, notice it picks up the outside profile between the square and the solid circle. But notice it does not isolate the dotted circle. It does isolate the centerline square, the thicker centerline square, but it does not isolate the thinner centerline square. Well, why not? It's all about that line format. So with circles and arcs, of course, can be solid, or if you select the geometry, come up here to the format panel and choose the very top option, that's your construction line option. Turns it into a dashed or dotted object line. Circles and arcs cannot be center lines. So if I come up here to the format, you'll notice there's a center line icon, and both of these icons function as on-off switches, basically. Notice I cannot change the line format of that circle to a center line, which seems weird, but I'll get back to that in a minute. So a construction object is not seen as a valid sketch boundary. So the extrude command, the revolve command, they do not see that construction object as a valid sketch profile. It is simply there for construction purposes. Now let's talk about a line segment. And of course, this applies to everything else: rectangles, slots, polygon shapes, what have you. 4 different options with line segments. Of course, the option of a solid line, or if I select that line, I can invoke the same construction option, turns into that dotted line. I can also select a line segment, turn it into a center line, and you'll notice it's a bold center line type. If I select the final one and I turn on both of the switches, not only is it a center line, but it's now a construction center line. So in this particular scenario, the only 2 that function as a valid sketch boundary is the solid and the center. The 2 that have construction as part of their creation, they are not valid sketch boundaries. So back to this case right here, that's why this particular square, each one of the little triangles is seen as a valid sketch boundary because it's nothing but center lines. Whereas this one is not, because it is entirely made of construction center lines. And same for the circle, it's construction only. All right, now let's talk about degrees of freedom. So looking in a sketch, go back to this guy that we pulled in from AutoCAD. If you look at this and you kind of find where the missing pieces are, whenever you look at a sketch, Inventor is giving you some feedback on what you need in order to fully constrain that sketch. So if you look in the bottom right-hand corner, it's telling me there are 4 dimensions needed to fully constrain this sketch. And you might look through this and think, no way, everything's got a dimension on it. Everything's good. Now, one way you can check that, there's multiple ways to do this, but one of the ways you can check it is you can turn on all of your constraints. So across the bottom of Inventor, when you're in the sketch mode, you have 6 different status bar icons. And the second icon allows you to show all constraints, and that basically turns on the glyph on top of every object that has a constraint associated with it. So as you hover around each one of these, it highlights the corresponding object that the constraint exists for. So this is one way of diagnosing and finding maybe pieces of geometry that are not constrained and need to be. The other option is to look at degrees of freedom. So second from the right, kind of looks like a 4-way lug wrench and a light bulb. This is the degrees of freedom status icon. When I click on this, it turns on all these red arrows. And there's a lot of red arrows in here. You've got some red arrows that are 2 directions. So if I zoom in a little bit, you got this guy right here, which basically means this horizontal line can move up and down. Then you've got a 4-way arrow, which means that point can move in all directions, or both directions, X and Y. Then you've got the rotational arrows, which basically says this horizontal line can pivot or rotate around. So anytime I see a rotational arrow, step 1 for me is to put a vertical or horizontal constraint on that object. So if I come in here and I put a horizontal constraint on my top line segment, you'll notice that 95% of the degrees of freedom disappeared. That one constraint took care of the bulk of that movement. Well, why? If I come back and I look at my constraints, it's because this one object is parallel to this one. And man, does this one have a lot of constraints. So most of the objects in this sketch are associated with this bottom horizontal line segment. So that's why this one got all of them to move and reconstrain. Now, I've got a few left that I need to take care of. So for something like this, maybe collinear between those 2. Try that again, didn't grab it. Collinear between, oh, wrong one, that's coincident. Try it again. Collinear between these 2 lines. That took care of those degrees of freedom. And then horizontal alignment between the center point of that circle and the center point of that circle. Now, if I look down the bottom right, you'll notice I don't see any degrees of freedom. But if I look in the bottom right, it says 1 dimension needed. This can happen sometimes when you pull in geometry from AutoCAD, where it may not show a movement or a degree of freedom. That particular point right there can move a little bit. So I'll do the same thing here, put a horizontal constraint between those 2 points. And as soon as I get that sketch fully constrained, that's when Inventor tells me it's now fully constrained. It's not going to go anywhere. So that's a very quick way of diagnosing your sketches with degrees of freedom and showing and hiding all of the constraints. Also, whether or not you have show constraints turned on or turned off, when you select a piece of geometry, the various constraint glyphs that are associated with it will show up. So if I click on this one here, I'm getting all of these other constraints that are shown up. So you can show all of them, or you can do it one at a time. The other thing we're going to look at is the dimension display. Also part of the status bar icons is the ability to change how the dimensions are giving you information. So right now we're looking at a decimal format of all of these dimensions. But if I come down here to the third icon from the left, if I pull that up, I have 5 different types of dimensions I can show. The default is tolerance. And if you configure any tolerancing for your dimensions, you'll see that show up here in the sketch. I can change it to an equation, which essentially shows me the name of the parameter and then what the value of that parameter is. If I change it to the name only, then you lose that value. You're only dealing with the dimensional names. You can also just look at the value, which essentially is the same as tolerance, but you just don't see the tolerance if there's a tolerance associated with it. And then lastly is the precise value. That's all of the decimals that Inventor can calculate to. And again, tolerance is your default. Another thing to look at is as you are sketching, Inventor is doing a couple of things to kind of help you out. It's trying to reestablish or associate relationships between geometries. So we're going to talk about constraint inferencing. So as I'm moving around with this new sketch line that I'm making, it's trying to constrain it vertically or horizontally. Also, if I hover or touch, I'm not clicking, by the way, just touching on some of these other objects. When I move around, now it tries to establish relationships with those other objects. So there's a parallel. If I come back to this one, it can go perpendicular to that one. And as I move around, it's trying to rebuild and reestablish all of those relationships. You'll see those glyphs pop up every now and then. There's a coincident right there. There was another perpendicular, another parallel shows up. If you're doing this in a very busy sketch, that can kind of be a nuisance. So what you can do to temporarily turn it off, hold down the control key. As long as I have the control key held down, Inventor does not perform any constraint inferencing. Even if I hover on these objects, it does not try to establish any relationship between them, so long as I have that control key held down. As soon as I let go of it, inferencing comes back. Here's another one, comes up a lot. Left clicking to accept an aligned dimension. Well, what that means is, of course, you can dimension vertically, you can dimension horizontally, but then you get to this angled guy right here. Now, if I click on that and I pull up, there's a horizontal dimension. If I pull over to the side, there's a vertical dimension. Of course, you can also right click and choose aligned, and that gives you this. We can also do this without the right click, which is a little bit slow, let's be honest. So if I click the dimension, click that object. Now I'm going to zoom in here a little bit so we can see this really good. When I zoom in, you'll notice there's a small angled dimension glyph right there at my cursor. Kind of hard to see, but it's there. If I get up too high, it immediately goes to a horizontal dimension, or if I go too far over, automatically goes to a vertical dimension. But if I stay close to where I see that angled dimension glyph, if I left click, it automatically goes to an aligned dimension. You just have to see that angled glyph in order for this to work. Otherwise, if you get too far out, you've got to right click to get to the aligned option. If you stay close enough in and you just left click, it defaults to an aligned dimension. If you have a lot of angled geometry in your sketch, that's a big time saver too. The last one for this particular file is naming a dimension and setting the value in a single operation. So every dimension you create, let me bring those two back. Every dimension you create becomes a parameter. And of course, you can go into the parameter manager and you can rename these dimensions, no problem there. If you get a lot of dimensions in there, it can be a little bit confusing. So one thing you can do is name as you go, or even after the fact. So I'm going to create a dimension on this vertical line, and when it comes up to edit the dimension, I'm going to type in a name, and I'm not going to use spaces. I have to use underscores because you cannot have spaces in the parameter name. So I'll just call this profile height, and I'll say equals, and I'll type in what value I want it to be. We'll say 5.25. I'll press enter, and of course the dimension changes to the height that I specified. I'm going to keep doing this on that particular line segment. Same thing here. I'll say call this, I don't know, what are we going to call this? Smaller profile height equals, and we'll say 3.5. If I go check out the parameter manager, what you'll notice is those parameters have already been named and their value has been specified. The key takeaway there is you have to type out the name. Again, it cannot contain spaces, and you have to use the equal sign because you're defining here's my name and here's what that value equals. Let's see. Oh, auto project origin. Let's go to that one. Here's a very popular one that comes up quite a bit, especially with new users, but even us seasoned veterans, it bites us sometimes. It happens. So I've got this sketch here, and I've got everything in here dimensioned. Well, almost everything. I don't have this dimension, so let me get that dimension. All right, so that should have it covered. Just like our AutoCAD sketch that we looked at, everything has been dimensioned, but Inventor's saying, hey, wait a minute, you need 3 dimensions to fully define this. Well, I need to either locate this to 0, 0 or dimension it relative to 0, 0. And you'll notice in my sketch, there's a small yellow dot here. Now, in your setup, that dot may have a different color. It's all dependent on what your color scheme is. So the dot presence is the most important thing. That is your projected origin. Okay, well, what is that? That is your 0, 0, 0, where X, Y, and Z meet. That's what that is. That's what that dot represents. Now, you can accidentally delete this or purposely delete it. Your sketch still knows the coordinate system. It still understands where 0, 0 is, but I cannot dimension objects relative to a coordinate. I can only dimension between objects. So if I try to dimension this line from here to that point, there's no point there. It's telling me it already exists because I already got it there, but there's no point here to dimension to. I have to get that point back. So if I accidentally deleted it, here's how you get it back. Project geometry, just start that command, expand your origin folder, and select your center point. That's it. You're done. That's all you needed. You now have your dot. Now you can also get this to show up every time you start a new sketch. Under Tools, Application Options, if you look on the Sketch tab, there's a checkbox down here, auto project part origin on sketch create. So every time you make a sketch, it will reproject that 0, 0 to your sketch so that you have a locator point to dimension to if needed. On the initial sketch, it's a must, but on following sketches, you might not need that if you're dimensioning to other object faces and edges. Now, I talked about sketch blocks in your templates. Let's look at that in a little bit more detail. So in a sketch environment, you have the ability to create sketch blocks. And if I look in this particular one, under this sketch, I have two different blocks. I have a flywheel and I have a guide. Also in the blocks folder higher up in the tree, I only have those two sketch blocks. These are standard Inventor sketch geometry that I simply unified it into a block. Well, how do you do that? Okay, I'm going to create a linkage arm connecting the flywheel and the guide. So to do that, I'll just use a line segment, use an arc. Sorry, right click. Try that again. Okay, here we go. And we'll go about right here and close up that shape. Oh, quit. There we go. All right, I'm going to dimension this. Let's make it, say, 7/8. And I'll do a point to point. And we'll make it 12 inches. Okay. Now, if I grab any one point of this, you see it wants to resize. There's a few constraints that I don't have quite right. So I can fix that. There we go. Now if I try grabbing it and moving it, doggone it. Still got something that's a little out of whack. So this can happen with sketch skeletal modeling. You can have things in your sketch that aren't quite finessed the way they need to be, but you need to get a skeletal model together. What I can do is quit fighting with this, and I can just take all of that and stitch it together as one block. So if you look on the sketch ribbon tab, there's a layout panel. If you don't see that panel, right click on any of these other panels, go to the show panels flyout and make sure layout is turned on. That's where you get to the creating block option. So I'm going to create a sketch block. Simply call this a linkage. Geometry I'm going to select is all of that geometry. My insert point is here. Hit OK. Now I have that unified as one block. I can move it anywhere. Notice it doesn't get all out of whack on me anymore. I can use my constraints. Line that up horizontal to here and here. Now I can actually create an animation of sorts. Just by dragging components around, I can see, okay, is my linkage long enough? Well, no, it's leaving my guide. So I need to edit that, increase its length. So I'll edit that block. Let's make it 16 inches, see if that's long enough. Run an update. All right, so that put it back inside. Try moving it again. If I grab that center point. Now, is it too long for the other end? All right, looks like we're good on the other end. We could have been too long. We could have been too short. You know, maybe the guide itself could have been too short. Same thing. I could right click, edit that block, change the dimensions of the guide, run my update. Everything stays reconstrained and I have larger sketches to work with. So sketch blocks are incredibly powerful for performing skeletal modeling inside the part environment. So let's look at the standard parts. One option you have is to rename features of the browser. This can help when you're trying to identify particular operations with particular features and machining operations out in the shop. So you notice looking at this particular hairdryer model, I've got some of these items have been renamed. There's a barrel length, there's a barrel curve. Some of them have not. If I get down here, here's a sweep, and I'll just do a slow double click, or you can do an F2 on that, or you can right click and hit rename. And I'm just going to call this the barrel. You can have spaces in here, perfectly allowed, not a big deal there. This one here, I'm going to rename it to the handle. And you can rename any of these. You can rename the sketches, the features, perfectly allowable. Next, we're going to look at displaying some extra information in here. So not only can you rename it, you can also show additional information. So if I come down to different part file, got some extruded blocks, some fillets, some chamfers, pretty generic, what you see over here in the browser tree. But if I go back to my application options, if I go to my part tab, there's a checkbox, display extended information after the feature node name in the browser. When I turn that on, now all of the features show additional information. And you'll see that for things like the fillet, it's showing me the size of that fillet. For the drilled hole, it's giving me the actual configuration of that hole, the information about that hole. It's a tapped hole. It's a 3/8 16 UNC. So again, this is an option that you can turn on and off, and it affects all parts. So it's not just this part does it, that part doesn't. It's all of them. Another option you have, streamline option here. Whenever you are applying fillets or chamfers, of course, you can do an individual select of each edge if you want. So if I create an edge fillet, I can come around and I can select individual edges if I want, or I can actually come out and I can window, and it'll pick every single one of those edges. Same thing happens with chamfer. You can pick individual edges, or you can window to select multiple edges at once. Now I picked something in here that can't be chamfered. That's why it's not giving me a preview, or the chamfer size is too big. Okay, size was too big. So you can run into a situation like that if you're selecting some stuff that you didn't need to, or that is not large enough to accommodate whatever size you're working with. But you can perform window selections for fillets and chamfers. Another one we're going to look at is the delete face command. So let's simplify this. As you get going into intermediate modeling and advanced modeling, you're going to end up with some features that you could consider to be extras that you didn't need. Something like this is pretty easy to take care of. Standard extrude, cut, and it's gone. But other features, not so easy to take care of. You can, within reason, use the delete face command. Now, as the default delete face settings go, heal is turned off. Out of the box, it is turned off. What does that do? Well, if I pick these two faces with the healing option turned off and I hit OK, those faces are gone, but you just now turned your solid into a surface. You'll notice that you can see inside of it. So that's not the option you want. If I come back and I use delete face, pick those two faces, turn on the heal option and hit OK, I get a nice clean result because it removes that geometry and patches it up. Now, I say this with a little bit of fine print associated with it. The more advanced the geometry, the more time this tool will take to run, and the results might not be what you're after. So take, for example, if I come in here and I want to delete this end rib, just this rib, not everything else. Watch what happens when I use the heal option. First, you're going to notice it does take longer to run because there's a lot more geometry in here. The heal option is trying to patch up what you told it to get rid of, and it's trying to keep everything else, but it's also trying to figure out what should stay and what shouldn't stay. Now, you could run into situations where the command just runs and runs and runs and runs and runs and won't delete anything. In that case, you've locked up Inventor, which I might be on that road now. I don't know. But you could also end up with a result that is not what it should be. It got rid of too much stuff, or it didn't get rid of enough. So use the delete face and the heal option after you've hit save. That way you don't lose any of your file geometry. And I'm going to say I might not have picked enough, or I might have picked too much. So this one has gotten me stuck. Next, after this, we're going to go into assemblies. and talk about building folders in your tree, in your browser tree, to better organize. We've also talked about pre-building your assembly template with virtual components, and unfortunately I'm going to have to kill Inventor. Apologize about that. Let me kill that and relaunch. So I threw a little bit too much at it. Bring it back over. All right, so let's talk about the assemblies and the folders that you can create. So working with any assembly, no matter how large, how small that assembly might be, you might need to organize your browser tree into something that's a little bit easier to navigate. And one option you have is to create browser tree folders. When I create a new folder, I can name it whatever I need to name it. A lot of times fasteners would be a good one to start with, so that I can take all of my fastener components, all of my bolts, nuts, pins, washers, and simply drag it and drop it into that folder. This does not affect the bill of material, has no effect on it whatsoever. But if I expand that fasteners folder, I can see all of my fastener components that I put in there. And you can move parts in and out as you see fit. You can have another folder for purchased items versus manufactured items. You could have a folder for coated versus uncoated, that kind of thing. And again, there's absolutely no effect done to the bill of material. Let's talk about using the insert constraint, which is a faster constraint to work with. If you're placing components from the content center, especially bolts and washers, some of the pins will do this, but not all of them. Most of the bolts and washers have a function called auto drop. And what that allows you to do is you can hover on an edge, and Inventor will measure that edge and resize for what it thinks is the best fit component. When you select that edge, you do have the ability to follow the pattern. That's what this little checkbox does in the auto drop box. Now you might look at this and think, well, that's not a pattern. It is. In that plate, the holes were drilled based on a sketch pattern. But I went into the sketch pattern and I suppressed certain elements of those center points. That's why you get this kind of scattered look to it. But it still recognizes, hey, these were made from a pattern. So it will follow them and put a bolt in every single one of them. Very quickly, very easily. There's one, there's the rest. Now, what if you're working with something that is not from the content center? Maybe you're working with something that you downloaded. Could be a special fastener or something like that. What's the quickest way of getting these components in there? Well, you can use, of course, centerline mates and face mates. So I could centerline and centerline that, apply it, face mate here and here, apply that, and then the same thing. Centerline of the bolt, well, try again, pick the wrong thing. Centerline of the bolt to centerline of the hole, and then lastly, underside of the washer to the top of the plate. That works. That was 4 different constraints. Let's cut it in half. The way you do that is to use a different constraint known as insert. Insert is fantastic for fasteners. That's where you really get the power of it, but it works for anything. With the insert, I'm selecting circular edge and circular edge. Notice the center line is calculated based on the normal of that circular edge. Apply that one. Circular edge to circular edge. Done in half the time with half the clicks. So if you've got a bunch of these that you've got to put in some kind of scattered pattern like this or scattered placement, the insert command can save you a lot of time. Let's see, what's next on our list? Oh, bill of material structure. So when you have an assembly such as this, you've got a shop table and a vise. If I look up here and I run an iProperties check on this, it tells me this thing weighs right below 85 pounds. Well, I'm not going to put 85 pounds on the product packaging for my vise. That'd be a vise the size of a microwave. It's just this little guy, this little 6-inch vise. It does not weigh 85 pounds. So why am I getting 85 pounds? Because it's reporting the table. But I need the table there to lay out my vise correctly, make sure I got good clearances and stuff like that. I want to see that table there. What I can do is I can go into the bill of materials editor, take the bill of materials structure of the table, double click on that, and I can get a pull down. I can change it to any other type of structure. Now, you might think, okay, well, let's make it phantom. If I make it phantom and I run the iProperties again, no change. It's still 85 pounds. But if I go back and I make it reference, say done, rerun my iProperties, now I'm down to just under 12 pounds. Anything marked as reference in your bill of material, that component is not factored for your mass or your center of gravity or your moments of inertia, your inertial properties. Any component marked as reference. Also, by default, reference components do not show up in drawing views. You can manually get them there, but they don't show up by default. All right, let's look at sectioning in an assembly and what happens when we try to section content center components. Primarily happens with fasteners, of course. That's the most commonly used items out of a content center, but it happens with all content center items. If I look at the View ribbon tab on the visibility panel and I generate a half section, let's say I go right down the middle on that plane. There's an option in your application options by default on the assembly tab. There's a checkbox for section all parts. By default on a new install, this is turned off and your results look like this. Content center components are not sectioned. So you can turn that on. Again, this is graphical. If I go back into the application options, assembly tab, turn on section all parts, hit OK, it now sections those content center items, which for the most case, no, we don't really care about seeing content center parts sectioned like that, but for clarity, sometimes this is needed. Another thing to discuss with the content center real quick. Let me go back into, you know what, I'll just use that same assembly. If I place a component from the content center, let's go with the hex bolt, and I'll just drop it out here in space. When I place it, I'm presented with this dialog box to make some choices. Let's say 3/8, 2 inches long, and UNC. Bottom left-hand corner, I have two options. I can choose as custom or as standard. What's the difference? As custom, when I click OK, Inventor is going to ask me, where do you want to save the IPT that gets created for that configuration of component? Say OK, brings it up. Where do you want to save it? There's your file name. You can change your file name, change your save location. That's what as custom does. It asks you, where do you want to put it and what do you want to call it? If I do this again, but this time I choose, I'll choose the same options just to be apples to apples. If I choose as standard, I don't get prompted. It simply places it, or I place it out in the modeling area somewhere. The reason I don't get prompted with as standard is because it goes back to your project file. So if I look at the project manager, look at my current active project, under folder options, there's a path for content center files. As standard puts content center components in that location. This is not the location of your source databases. That's not what that is. This is the location of the files you have placed from the content center. And that option is set in your application options on the content center tab. You can choose the default to be as custom or as standard. But again, you can change it during the placement. And then the path to the source databases is listed here. All right, let's look real quick at presentations. The one I wanted to pull out for presentation is one that comes up a lot when you have tweaks to components that you've done. So as I step through this, you'll notice, of course, the pins come out, the central body comes out, I get a camera movement change, and then I get 2 bushings on one side and then 2 bushings on the other side. Why don't I move all 4 bushings at the same time? It's a little bit more efficient, a little bit quicker animation. That's easily done once you apply your tweaks. So once you define your component movement, they'll show up down here in the storyboard, and it's simply a matter of rearranging and moving the animations so that now as I step forward, you'll notice all 4 bushings move at the same time. So that one's a pretty simple one to work with. All right, we're moving into drawings. One of the most common ones I get with drawings is, well, we've got this component here. This is a left-hand thread. I need to make another one just like it, but it's a right-hand thread. And that's the only difference, the direction. So first off, let's make the part. So I'll just do a save as and rename this to the right-hand thread direction. Now, of course, modeling wise, I need to make a change here. I need to change the thread direction. So I'll come in here and tweak that coil, change it to a right-handed thread. Perfect, looks good. Save that, close it. I already have a drawing of the left-hand thread configuration. There's my left-handed thread. I need to make another one where the only thing that's going to change is that thread direction and this little note. Everything else will be identical. How can I do that? Well, obviously first you would save this as your right-handed thread configuration or right-hand direction configuration. Once that's done, on the Manage ribbon, there is a command to replace model reference. Brings up this utility. You could have multiple sheets and multiple views, but we only have one sheet and one view. It's just basically saying this is what this particular sheet is looking at. It's looking at this component. I can browse and choose a different component. So I'm going to choose the right-hand configuration. I'll say open that, and I get a prompt simply asking, are you sure you want to do this? I'll say yes. Nothing has changed yet on the sheet, but when I hit OK, you'll see a quick flash, and the only thing that will change is that thread direction. None of the dimensions will be orphaned. None of them will be lost. Done. And now when I zoom in, you'll notice the thread direction has changed. I only need to update the note because I manually typed in that note. That's the only reason this did not automatically change. Something else with drawings is when you're working with dimensions, when you go to create a dimension, for example, let's say I come in here and I create this in dimension here. When you create the dimension, you have the option up here in the format panel if you want to choose what dimension style you want to use. Otherwise, it's going to use the default style that you have specified in your styles editor. So you have that option during the creation. But what if you mess up and you forgot to choose that? Well, I can take that dimension, I can select it, come back up here to the format, pull that down, and I can change it. Maybe I change it to a default millimeter. Or if I change it to a millimeter and inch dual units, I can do that. What I really want is to change it to my standard, my Husky dimension standard, which changes the text size, the precision, and the color of the text. How do I get that on all of these other dimensions? You can individually select them. You could do that. You could hold down the control key, the shift key, and you can change multiples at once. That is one option. The option I like to use best is change one dimension, right click on it, choose copy properties, and then you can individually select the dimension, say that one, or you can zoom out, and window the entire drawing, and it has changed every single dimension in that one operation. The fastest way to change your dimensions to the correct dimension style, hands down. Let's see. 2 more for the drawing environment. We need to look at sectioning all parts. So we talked about this in the assembly mode. We've got a top view here. We've got a section line cut and a section view down here. You'll notice the hardware has not been sectioned. Again, these came from the Content Center. That application option that you saw does not affect this. That's only for the assemblies. How do we get these components sectioned? There's a couple of ways to do it, but probably the easiest way to affect all of them is over in the browser tree, locate your view. So if I expand this out, there's my section view right there. If I expand that, it shows me the assembly. Expanding that, I can see each one of the components. And of course, the Content Center components are very obvious with their icon. I can simply do a shift select to grab all of those, right click, go to the section participation flyout and tell it section. And immediately those components get sectioned. Last thing to look at is the parts list filtering. So when you're working with an assembly, you might have different needs of taking your parts list and tweaking it. Maybe you have a general arrangement that shows everything. Then you might have a second or third sheet that is purchased items only, and you want the parts list to reflect that. If you double click on your parts list to edit it, brings up the parts list editor. Top left-hand corner, there is a large icon to apply some filter settings. This allows you to say, well, let's only show any items that get ballooned. So you could go ahead and pre-balloon the items, and your parts list will filter based on what items you've ballooned. You could filter based on a number range. You could filter based on purchased items. So if I apply that and say purchased items only, you'll notice my parts list gets condensed to only display or only list the items that are purchased. Now for the ballooning part, I have to go through here and manually balloon those items, or I could use the auto balloon, but it's not going to pick up purchased versus not purchased. So thank you everyone, and I appreciate it.